Hello guys. Let us discuss briefly the concept of unbalanced Wheatstone bridge and how to find the direction of current flow in an unbalanced Wheatstone bridge. So briefly, balanced Wheatstone bridge. What is balanced Wheatstone bridge? Balanced Wheatstone bridge. See, if you have four resistors connected like this, so this is A from here. If four resistors P, Q, R, S, P, Q, R and S are connected between A and let us say C. Let us mark this as a C. This is C. So this is A. Let us mark this is B, C and this is D, so that A and C are connected to a cell or battery of EMF E volts or V volts. Okay, either way you can take. Provided between B and D, if you connect a galvanometer having resistance G, then what this balanced Wheatstone bridge says, the bridge is said to be balanced. Bridge is said to be balanced if current through galvanometer is 0. Current through this galvanometer, you can mark this as Ig, is equal to 0. If Ig is 0, bridge is said to be balanced. So by applying this condition and of course by using Kirchhoff's laws, we can say the other expression, or you can say the condition for balanced Wheatstone bridge in terms of resistance is given by, you can say, balancing condition of Wheatstone bridge in terms of resistances, in terms of resistances PQRS is given by P by Q is equal to R by S, or P by R is equal to Q by S, or PS is equal to QR. If any of these conditions obeys, then the bridge, Wheatstone bridge, is said to be balanced. Okay, fine. But if what if P by Q not equal to R by S? If P by Q equal to R by S, the bridge is said to be balanced. Then no current passes through the galvanometer, and hence no current passes through means the potential at B and T are said to be same. If the usually current flows from higher potential to lower potential. If there is no potential difference, means no current flows through galvanometer. So as no current flows through galvanometer, this resistance of the galvanometer plays no role, and hence we can ignore it. And by removing it, we simplify the circuits and we try to work out with such kind of circuits. But unbalanced Wheatstone bridge means what? Let us see here now. Unbalanced Wheatstone bridge. Unbalanced Wheatstone bridge. Unbalanced Wheatstone bridge. So in the same circuit, if P by Q not equal to R by S, then the Wheatstone bridge is said to be unbalanced. Then the Wheatstone bridge bridge is said to be unbalanced. Unbalanced means what? If P by Q not equal to S, if P by Q equal to R by S, then Wheatstone bridge is said to be balanced. But if P by Q not equal to R by S, then Wheatstone bridge is said to be unbalanced. So if it is balanced in this circuit diagram, if you see no current passes through galvanometer and the galvanometer shows zero deflection or no deflection, and hence we can redraw the circuit without that galvanometer resistance, and we can calculate equivalent resistance of the circuit or current in the circuit, etc. But if this happens now, you can say you can draw the diagram like this. This is A, okay, it is C, okay, somewhere here. Series B, somewhere here is D. So let us mark one resistor here, another resistor here, another, another. P, Q, R, S. If these are balances, the galvanometer, no current passes through galvanometer, so we can remove it. But if in this case, here I have to say if P by Q not equal to, if P by Q not equal to R by S, so that means current through galvanometer is not equal to, is non-zero. Means if there is a galvanometer, then current through galvanometer is non-zero, Ig. Okay, here we have to be very careful about here. That is what you are going to understand. Whether here I have marked the arrow from B to D, right? So here what you have to understand is current. If you connect this to a battery like this to a key, of course, a battery of EMF here we hold B. Current I will be drawn from this. That current I will flow here. This I will divide into two currents. You can take it as I1 and I2. This, if it is balanced, no current passes through a galvanometer. No current passes through galvanometer. But if it is unbalanced, the current I1 comes here and it may divide into Ig and I3, and this Ig comes here and I2 combines and may flow here. Otherwise here I2 will comes and it divides into this, you have to take it as Ig may flow from D to B also. There is a possibility of current to pass from D to B. Then that current coming from D to B will combine with I1 and flows as I3, and here this flows here as I4. I3 I4 combines and gives the total current like this. This is point C. So how to find the direction of flow of current in unbalanced Wheatstone bridge is the question now. Okay, so write down the heading. Now your main heading should be to find the direction of current. Same circuit again you have to draw. Okay, to find. Now note down the heading. To find the direction of current. To find the direction of current in an unbalanced Wheatstone bridge. In an unbalanced Wheatstone bridge. Right, very good. So to find the direction of current in an unbalanced Wheatstone bridge. So very good. When the Wheatstone bridge is said to be unbalanced, if P by Q equal to R by S. When it is unbalanced, if P by Q not equal to R by S. Okay. In such case, what you have to understand is, if it is balanced, you have to just deal few other things by comparing with the balanced Wheatstone bridge case. If it is balanced, So this will be the circuit P Q R S. A B C D. If it is balanced like this, you can remove the galvanometer and its resistance can be removed. So whatever current comes here, it divides. So this current flows like this, and this current flows like this. So P and Q are said to be in series, and R and S are said to be in series. So those P plus Q and R plus S will be in parallel, and hence this will give the resultant. Right now, what you can understand from this is to understand in which direction a current flows in unbalanced. If it is unbalanced means no, some current will flow through the galvanometer. Okay, so to understand the direction, you have to consider without galvanometer, and uh, just to say that in balancing case, here if you say, yeah, so in balancing case, current, same current, let us say this is I1, this is I2. I1 flows, same I1 flows through Q also, P and Q, and same I2 flows through RDS. Right now, if you consider the potential difference between A and C will be fixed, is constant. Same A and C. It means if it is ABC and ADC, both will be same. Okay. Here we have to just write like many points step by step. V across ABC should be equal to V across ADC. V across A and C are constant. That means it may be for ABC part or ADC part. They will be same. And that you can also apply here the potential drop across A and B. If you express VAB, you can express as current is passing from A to B. You have to say current flows from higher potential to lower potential, and hence you can express it as the potential difference is VA minus VB. The potential at higher potential point A minus potential at lower potential point B. This is equal to, from Ohm's law, V is equal to IR. Here VAB, potential across A and B, which is that is nothing but across the resistor P, is equal to IR. I here is I1 into its resistance is P. I1 into P. But as earlier I have discussed, and I have just for your understanding purpose, just I have shown here. You can go through that, and you have to remember that. See here in this. Yeah. So according to this, as by using current divider rule, we have to say, if you remember this, is I equal to V by R effective. We have to calculate first R effective. In balanced case, R effective is P plus Q by P plus Q into R plus S by total resistance. Okay, and here as V is equal to I into R effective. I into R effective. R effective is P plus Q into R plus S by P plus Q plus R plus S into I. That gives V. V means V across A and C, right? But if you want to know what is I1 in terms of total current, then if by substituting this V here, you'll get total current. You'll get total current. Or in terms of total current, if you want to know what is I1, I1 is nothing but, so from Ohm's law, I is equal to V by R effective, but I1 is nothing but potential drop across this by that resistance. So here, the same I1 will pass through P and Q both. So the effective resistance across AB you have to take I1 is equal to V by V means V across A and C by the effective resistance between A and C, including this point B. So ABC, okay, ABC in the figure, this one, right? Now by taking this over here, I1 is equal to um, we have, as you know already, V is this V by R, so into R. But here R ABC part is P plus Q, P plus Q. And substituting and simplifying, we'll get I1. This is I1. This we have to make use of here. Let's come back. Yeah. So this that is nothing but your I1 in terms of I. So it is equal to R plus S into I. Okay, that you can write I afterwards by taking this P here into P by P plus Q plus R plus S, total resistance P plus Q plus R plus S into I. You have to go through that once before, then only you'll understand, guys. If you are having an idea, that is then no, okay, no problem. This is your VAB or VA minus VB. You can take this as equation 1. Whereas V across A and D, if you take VAD, so that is a potential difference across the resistor R. VAD is equal to, as current is passing from A to D, A will be at higher potential and D will be at lower potential, so we can write it as VA minus VD is equal to, from Ohm's law, potential difference across the resistor is nothing but IR, current through that resistor into its resistance, that is I2 into R, that is equal to, again I2 in terms of the resistance and total current is P plus Q. I told already the I1 is nothing but according to current divider rule, the opposite resistance by total resistance. I2 is opposite resistance by total resistance. Opposite resistance is P plus Q here. P plus Q by total resistance is P plus Q plus R plus S, into the here across R we want, so into R into total current, in terms of total current we want, actually this is into R, actually I. So here we keep R first, then we'll take I. So equation 2. Now from 1 and 2, to understand in what direction current flows in an unbalanced Wheatstone bridge from B to D or D to B, let us try to understand which potential is higher. Always current flows from higher potential to lower potential. Whether potential at B is higher or D is higher, we want to know. For that purpose, let us mark here what is VB minus VD. For that purpose, let's consider from 1 and 2. 1 and 2. From 1 and 2, if you add, if 1 and 2 will get VA minus VB plus VA minus VD. So 2VA minus VB minus VD, etc. But if you remove VA by doing some operation, mathematical operation, that is here obviously what do you call a difference operation, you can say, that is V1 minus 2. Let us mark here clearly 1 minus 2. VA minus VB minus VA minus of VA minus VD gives you minus VA plus VD. So we'll get VD minus VB. 1 minus 2 if you do, VD minus VB will get, otherwise we want VA minus VB. Okay, so here let us take 2 minus 1. This implies we'll get VB minus VD. So you have to just you can mark here for your understanding purpose. 2 minus 1 means VA minus VD minus of VA minus VB is equal to VA minus VD minus VA minus of minus plus VD. Yes, sorry, plus VB. So minus VA plus VA cancel, minus VD plus VB, that is VB is positive, VB minus VD. VB minus VD, that we have taken, that have taken directly here. 2 minus 1 gives VB minus VD. Okay, because of this you can take, so VB minus VD as 2 minus 1 gives is equal to, if you observe here, P plus Q plus R plus S is common and I is common. So if you take that common terms out, that is, it is equal to I by P plus Q plus R plus S common into, you can write it as 2 minus 1, right? So P plus Q into R minus R plus S into P. Now expand it. This implies VB minus VD is equal to I by P plus Q plus R plus S. You have to just note down the step by step, guys, then only you can follow. Okay, so here if you expand P into R is PR plus QR minus of PR minus PS. Minus PR plus PR cancel, we'll get QR minus PS. So this you can write here like this: VB minus VD is equal to. So how can you write QR minus PS? What is that? I by P plus Q plus R plus S into QR. Yeah, QR minus PS. So if for current to flow from B to D, VB should be higher. When VB should, this is the potential difference you have got, the expression. You can take it as equation 3 also. Okay, you can take this as equation 3 also. So here you have to say, you have to take some cases, like special cases kind of. What is that is, if QR greater than PS, then we get a positive value. So that means positive value means VB minus VD will be some positive value. So if QR greater than PS, then what you can understand is VB will be greater than VD. So you get a positive value of potential difference. Okay. So if QR greater than PS, VB should be greater than VD, and hence current flows from B to D in circuit. CKT means circuit. In this circuit, current will flow from B to D if VB is greater than VD. If VB is greater than VD. If VB is greater than VD. When it is possible, if QR greater than PS. Similarly, if if QR is less than PS or PS is greater than QR. If QR is less than PS or PS is greater than QR, then if QR is greater, sorry, already have taken a greater, now lesser. If QR is lesser value, we will get negative value. So negative value means here VB minus VD. So negative value you are getting means VD will be greater, VB will be lesser. That means we have to say VB will be less than VD. So if Q are less than PS, then VB will be less than VD, and hence, if VB is lesser in the circuit diagram, if VB is lesser than VD and VD is greater means current flows from higher potential to lower potential. So if you connect a galvanometer here, okay, current flows from higher potential to lower potential means from D to B. So that's what you have to understand. So if B is less than VD or VD is greater than VB. Yes, VD is greater, hence current flows from D to B. Hence current flows from D to B in the circuit. CKT means circuit. If both are equal, QR and PS are equal. If QR and PS in the equation 3 are equal, so QR minus PS will be 0. Potential difference between VB and VD is 0. That means VB minus VD is 0 means VB equal to VD. VB equal to VD means here both are having same potential, no current flows. Then that will be in balancing condition. That is what we can also draw as another condition. Here this is first condition, second condition, and as a third condition, if QR is equal to PS, then we can say VB is equal to VD. Potential at B and D is same means no current flows. Then no current flows through the galvanometer. No current flows between B and D or through galvanometer. No current flows between B and D. So these points you guys have to keep in mind regarding the unbalanced Wheatstone bridge. Unbalanced Wheatstone bridge, guys. I hope it is clear for you. You can pause the screen and try to copy every point. At any point, if you come across any confusions, you can drop a message, guys. right? Okay, then I'm winding the session. Yeah, one second. Let me just give you one question based on this. Actually, in one of the previous years, there's a few different questions I've asked. Let me give you one simple question, then I will wind up. So just note down the question. Um, yeah, where is that? One sec, one sec. Okay. Oh, where is that? Where is that? Yes. Yeah. So you can note down the question. This is actually asked in APMT 2006 and NEET 2006 actually. Okay. So note down a question. Question is APMT PMT 2006 question. So the question is, in the circuit shown, if conducting wire is connected between points A and B, the circuit shown in the circuit shown, comma, if a conducting wire, if a conducting wire is if a conducting wire is connected between points A and B, points A and B, then the current in the wire will the current in the wire will options are given. So the circuit is given and also options are given. So I'll give you the options here and circuit this over here, this at the side. You can draw the circuit first. So it is given that there is a resistor, one more resistor, here one more, and here the fourth resistor. Four resistors are given. The values are given as 4 ohm, 4 ohm, and this is 1 ohm, this is 3 ohm, and these are connected to a battery of potential difference V volts. And here, yeah, what is this? A conducting wire is connected between A and B. Here, this is marked as A, this is marked as B. So, a conducting wire is connected here between. So, you can connect a galvanometer also, but here it is mentioned that a conducting wire is connected. If a conducting wire is connected, so here, obviously a current will be drawn from the battery. It will flow here and it will divide into two currents, I1 and I2 here. This I1 comes here because it is a conducting wire. It will try to flow through this. I1 try to flow through this, and here I2 also comes in contact with this. This also will try to flow through this, but in what current will flow in from A to B or B to A is the question actually. So options. Now this is the diagram. The current in the wire will, options are given as, first option is flow from A to B. Current will flow from A to B. Second option is will flow in the direction which will be decided by the value of V. Flow in the direction which will be decided by the direction will be, which means which will be decided which will be decided by the value of V, by the value of V. And third option says be zero. The current in the wire will be zero. Fourth option says the current in the wire will flow from B to A. Will flow from B to A. Which option is right? So from our previous discussion, how can you just immediately within 10 seconds you can answer this just by understanding how the resistors combinations are. If we take the left side, in the left side combination, this is P, this is Q, this is R, this is P is here, P is this, P is 4 ohm, and Q is also 4 ohm, that R is equal to 1 ohm, S is equal to 3 ohm. So just go back and observe and remember, if resistors are such that if QR is greater than PS, VB will be greater than VD. Here what are B and D? This top point is B, bottom point is D. In place of this, in our question, this is given as A, the top point is given as A, bottom point is given as um, B, right? So you have to say if see here, if QR greater than PS, where is Q, where is R? QR, the cross product of this diagonal elements, QR is greater than PS. Okay, so just for understanding purpose I'm drawing this lines. Okay, don't consider it as a clumsy thing. Yeah, if QR greater than PS, see here, the product of the right oof, the product of this right side ones resistors. Yeah, see here, the product of these two resistors is greater than the other two resistors. That is, if you take QR, so you have to just take consider this. If QR greater than PQ, if Q, sorry, if QR greater than PS, if QR greater than PS, then VB will be greater than, here VB means VA will be greater than VB. So current will flow from A to B. Okay, so current flows from A to B. Or first condition. Or second condition is if QR is less than PS, then VA will be less than VB, means VB is greater. Or you can say VB is greater than VA. So current flows from B to A. Current flows from B to A. That's it. This will decide. Now let's check the values here. QR is greater than PS. QR is 4 into 1 is 4. PS is 4 into 3 is 12. Right? PS is 12. So QR is less than PS. QR is less than PS. So VA will be less than VB. VB is greater. So current flows from B to A. So current flows from which one to which one? B to A. Which one will be the correct option in that case then? So current flows from B to A. That's it. This is how we have to understand without doing any calculations. Simple. If you remember the concept, you can answer within 10 seconds. Some of the questions, many of the questions I can say. That's it. Okay. Okay guys, then I'm winding. Just you guys go through